Hi everyone, this is a brief video to talk about how to put some of the lessons that we've learned about redox into practice using the examples of the Hindenburg reactions that we learned about. So these first two reactions really weren't part of the Hindenburg disaster. I don't believe this is how hydrogen was actually made for filling the airship. It's just two different reactions that chemistry teachers can use to create hydrogen in their class to show how hydrogen is explosive. Um, let's look at the second one first because it's a little bit easier to grasp. Now notice that we have hydrochloric acid here, and so if you see an acid, it doesn't always mean that you have an acid-base reaction and we aren't looking at redox. This is hydrochloric acid just reacting with a metal, not a base. So when hydrochloric reacts with aluminum, you get aluminum chloride and hydrogen. The chloride here you can think of as having a 1- oxidation state in both places, so it's not really changing, it's a spectator. The aluminum is going from 0 charge to a 3+ charge, which means it's gone up in charge or has been oxidized. The hydrogen is going from a +1 oxidation number, you can think of it that way, to a 0 charge, so it's been reduced. Okay. Now, here we have a slightly more complicated way to think about it. We have aluminum reacting with water, and this is happening in the presence of a base, sodium hydroxide. Um, the that ends up being sort of a catalyst to it, but you also end up making sodium aluminum hydroxide, which is getting us to a little bit too far afield. That makes things a little bit more complicated than we need to. Anyway, if we think about water being HOH in this instance, we can think about this OH here in the hydroxide being sort of equivalent to the oxygen and hydrogen in water. And so again, we're seeing something that's sort of like seeing a polyatomic spectator ion. The hydroxide and the OH here, it's not really hydroxide, isn't really being changed, but we do see aluminum going from 0 again to 3+. So it's been oxidized. And this one hydrogen in water has gone from having a positive oxidation state to a 0, 1, so it has been reduced. Okay, if we look at the last reaction, this is the actual explosion reaction where you have hydrogen gas reacting with oxygen, exploding and making water vapor. In both cases, we have pure hydrogen, the element, and pure oxygen gas, the element of oxygen. So 0 oxidation number or charge on either of those. And we know that in water, the oxidation numbers are 2- for oxygen and 1+ for the two hydrogens. So that means that hydrogen has gone from 0 to 1+, which means it's been oxidized, and oxygen has gone from 0 to 2-, so it's been reduced. You could also use the biology trick with this one. Typically, hydrogen reduces and oxygen oxidizes, which means that if oxygen oxidizes, that means it's being reduced. If hydrogen reduces, that means it's being oxidized. All right, I hope that this helps and that this has cleared up some of your redox questions for you.